Okay, so the topic is Wheatstone bridge. What is a Wheatstone bridge? It is an arrangement of four resistances shown here. You can see this is P ohm, this is Q ohm, this is R ohm, this is S ohm. Okay, so these are four resistances which are connected as shown. This arrangement in which there is a galvanometer in the middle arm and there is a battery and a key. This arrangement is known as Wheatstone bridge. What it is used for? It is used to find out one of these resistances. Three will be known to you and fourth one we'll have to find. So this is used for that purpose. Okay. The name, or you can say the structure, was suggested by or devised by for the first time by scientist Wheatstone. So after his name, the structure has been named. Okay, so you can read here, it is an arrangement of four resistances which is used to determine one of these resistances quickly and accurately in terms of remaining three. Remaining three will be known to you. Okay, so you can see a proper diagram here as well. Again, P ohm, Q ohm, R ohm, S ohm. There is a battery. You can connect a key as well. And in middle arm, you have to connect a galvanometer. Okay, now Wheatstone bridge, we know that this structure is known as Wheatstone bridge. Now, what is a balanced Wheatstone bridge? Balanced Wheatstone bridge is whenever no current is flown through the galvanometer, like galvanometer remains at zero. Whenever there is a situation that no current is being flown through the galvanometer, in that situation, this resistance upon this resistance is equal to this resistance upon this resistance. This situation is called balanced Wheatstone bridge. If no current flows through the middle arm, then resistance P upon resistance Q is equal to resistance R upon resistance. This is called balanced Wheatstone bridge. So two things covered. What is a Wheatstone bridge? This type of structure is called Wheatstone bridge. And what is balanced Wheatstone bridge? If no current is flowing to the middle arm, then P by Q is equal to R by S. This condition is called balanced Wheatstone bridge. Okay. Now we have to derive this condition. We have to derive the balanced condition of Wheatstone bridge from Kirchhoff's law. It is ultimately an application of Kirchhoff's law. Be it potentiometer or this Wheatstone bridge, they all are applications of Kirchhoff's laws. Okay, so we are deriving this condition. Which condition? The condition of balanced Wheatstone bridge. So let us see. We'll be drawing a Wheatstone bridge. You can see this is P ohm, Q ohm, R ohm, S ohm. Middle arm is connected to galvanometer, and then there is a battery, then there is a key. Okay, now we'll be labeling the currents in this. So you can see from battery which current is coming out? I. Okay, now this current I will be bifurcated into two parts. From upper arm, how much current is going? I1. Out of I1 is going through upper arm, so remaining current, that is I minus I1, will be going through lower arm. Okay, so this I1 will reach here successfully. Now here again branching is there are two branches. Okay, so out of I1, Ig is going through this branch. Okay, and the remaining, that is I1 minus Ig, is going through Q. Okay, now through the lower arm, how much current was going? It was I minus I1. So I minus I1 and Ig will meet together. This is Ig. They will meet together and they will enter in this arm. I minus I1 plus Ig. Okay, now this current and this current will meet together and they will, you can see, again it will be I back to the cell. So this is how we'll have to label the different currents in different arms. It's easy. Now once you are comfortable with current, okay, you will have to apply Kirchhoff's voltage law in the loop ABDA. ABDA. And this is the order in which you are going. So you are going from A to B. A to B, how much is the voltage? This is the current and this is the resistance. So I into R, you can say I1 into resistance is P. Okay. Now because your direction is from A to B and current is also going from A to B, so this term has to be denoted positive. Further, it is to go from B to D. So when we go from B to D, you can see your direction and current direction is same. The term has to be positive. Now current into resistance. Ig is the current through middle arm and G is the galvanometer's resistance. Resistance of galvanometer is G. Okay. Coming to DA now. You have to go from D to A. That is your loop, closed loop. So it is again will be current into resistance. Resistance is R. So this is your current and this is your resistance. Why negative sign is there? Because you are going from D to A. But current is coming. You can see here this arrow. Yeah. Current in this arm is coming from A to D. So this will be denoted negative, which I have denoted here. So my equation is ready. Now, under balanced Wheatstone bridge condition, no current should flow through the middle arm. No current flows through the middle arm. So which is the current through middle arm? Ig. So it has to be 0. So you can substitute here 0. So your equation will reduce to this. Okay, negative term you can take that side. So this is your final equation, equation number 1. Now you will apply the same Kirchhoff's voltage law in the other loop, second half. So you can see I have named it as B, C, D, B. So let us see here B, C, D, B. Okay, so first we'll go from B to C. My direction and current direction is same. The term has to be positive. So you can see current into resistance. We'll have to note down the voltage. Current is this in this arm. I1 minus Ig. And what is the resistance? Resistance Q. So denoted. Now C to D. So your direction and current direction is opposite. So you'll have to write negative sign here. Then current into resistance. So current is this I minus I1 plus Ig. Yes. And resistance is S. So note it down. Then go to D to B. D to B, when you will go, you will find the current in opposite direction. So write negative sign here. Then current into resistance. Current through middle arm is Ig and resistance is G is equal to 0. Now again you will apply the condition of balanced Wheatstone bridge that no current should flow through middle arm. So put Ig 0 wherever it is. Here it is Ig and here it is Ig and here it is Ig. So please substitute. You'll get this equation. Take negative term that side. Right. So you'll get this equation. The two equations are ready. Now you can divide. See, I've written equation number 1 once again here. So I've divided 1 by 2. So you will get, you can see from here only, that what will be cancelled? I1 and I1 will be cancelled, and this term will be cancelled. So you'll get the ratio of P by Q is equal to R by S. So we have got the conditions of balanced Wheatstone bridge using Kirchhoff's law, that if no current is flowing through middle arm, then this ratio is true. This ratio holds good. So this proves the condition of balanced Wheatstone bridge. Now coming to the sensitivity of Wheatstone bridge, then sensitivity means the device should be able to measure even small amount of current. Okay, and it will be better, more sensitive if it can show large deflection. If the needle can show large deflection even for small values of current. So that is the meaning of sensitivity in case of Wheatstone bridge. So maximum accuracy and you can say maximum sensitivity is achieved when, number 1, this question is usually asked, when the order of all four resistances is same. When the orders of all four resistances is same, like they all four resistances are of same order. Okay, and null point is obtained in the middle of the bridge wire, that is Wheatstone bridge. Okay, now what are the advantages of Wheatstone bridge? Wheatstone bridge, first of all, it works on the basis of null point method. Okay, so in null point method what happens, internal resistance of the cell and galvanometer's resistance does not affect the calculation. So null point means no current. No current means neither you are drawing the current from the cell. So that means internal resistance of the cell and galvanometer's resistance do not affect the calculation. And similarly, here there are no calculations of current and voltages, because the ultimate aim is to find out the unknown resistance out of the four known. Out of 4, 1 is unknown, that is to be calculated. Okay, so there is no measurement of current and voltage. So resistances of voltmeter and ammeter also do not affect the calculations, do not affect the measurement. These are two benefits. Okay, benefits and sensitivity you can read it last. So meter bridge. Now next topic, which is quite important, meter bridge, other name is slide wire bridge. Okay, this is an application of Wheatstone bridge. This is an application of Wheatstone bridge, and Wheatstone bridge is an application of Kirchhoff's law. Potentiometer is also an application of Kirchhoff's law. So meter bridge. What is a meter bridge? It's the simplest practical application of Wheatstone bridge. Okay, that is used to measure known resistance. So Wheatstone bridge is a concept. Now we have applied it and we have constructed a device which is known as meter bridge. What is the principle? It works on the principle of balanced Wheatstone bridge. So what you will have to write that condition of balanced Wheatstone bridge once again, that if no current is flowing through middle arm, then this upon this is equal to this upon this resistance upon this resistance. So I have written the same. If no current is flowing through middle arm in the following circuit, then resistance of arm AB, which is P ohm, resistance of arm BC, which is Q ohm, resistance of arm AD, so these all will be equal. Okay, after that we'll have to go for construction of meter bridge. So you can see I have compiled certain pics available on the net. So this is your meter bridge. This is how it actually looks and available in the lab. We have certain experiment devoted to meter bridge. So you can see here construction, you can see there is a wooden plank, there are two L-shaped thick copper strip. This is one and this is one. There are two L-shaped thick copper strip. Okay, and one alloy wire is running like this. So one alloy wire is stretched between the two L-shaped copper strips. So this is your alloy wire. It is not visible because it is an alloy wire. Okay, so it is like this. Here also you can say these are two L-shaped copper strips. Okay, one more copper strip is there, thick copper strip is there, and similarly one more thick copper strip is there. You can see these are three bricks. Okay, now there are two gaps. One gap is this, yes, and one gap is this. Here also you can see this is one gap and this is one gap. So in one of the gap we will be connecting known resistance. In another gap we will be connecting unknown resistance, which is to be calculated. Okay, in one of the gap we will be connecting known resistance and another we will be connecting unknown resistance. Here you can connect known, that is K, and here you can connect unknown. Okay, unknown is to be calculated. Meter bridge wire is visible here. Now length of the wire is always 1 meter, so it is known as meter bridge. Okay, what is the purpose? To calculate the unknown resistance. So when we will discuss the construction we have already seen. Now let us give it a reading. There are two L-shaped thick copper strips on a wooden plank. One copper strip is also there between the two L-shaped copper strips as shown. Okay, an alloy wire of length 1 meter is stretched between the two L-shaped copper strips. Okay, and this wire is called meter bridge wire. There are two gaps left and right. In one gap connect known resistance and another gap connect unknown resistance. Now middle screw. So let us see middle screw as well. So this is your middle screw. Let me rub it off. Yeah, there is a middle screw which is connected to a resistance box and then a galvanometer. The purpose of resistance box is to prevent the galvanometer. Then galvanometer is connected to jockey. Okay, so you can see this is your jockey. Okay, there is middle screw. Here it is clearly visible. If you can see, it will be connected to a resistance box to prevent the galvanometer, then a galvanometer, and then it will be connected to jockey. Okay, so this is what I have written further. That middle screw is connected to galvanometer and then it is connected to a jockey. I have not written external resistance. If you wish, you can write. So you can see here in diagram, circuit diagram will be like this. So actually how it looks that we have seen, and now it is circuit diagram that you need to draw. So these are two thick copper strips, yellow color, yes. One more thick copper strip is there between these two. There are two gaps. In one they have connected resistance box. Resistance box means it is known resistance. And in one of the gap, this gap they have connected unknown resistance. Okay, then middle screw is connected to, directly they have connected to galvanometer and then galvanometer is connected to jockey. Okay, now one more thing is there. One end of the alloy wire, this is alloy wire, this black color is alloy wire, now it is red. Okay, one end of the alloy wire is connected to a battery, right, and then battery is connected to key and key is connected to next end of the alloy wire. This is how it is set up. You can see here as well. In this diagram also you can see these are two thick copper strips. Yes, one more copper strip. There are three screws. Okay, there are two gaps. In one gap we are connecting known. In one gap we are connecting unknown. It is not fixed wherever you can connect. Okay, now this is alloy wire. One end of the alloy wire is connected to a battery, then it is connected to a key, and the other end of the key is connected to the other end of the alloy wire. This is how it is set up. So experimentally your meter bridge is ready. Okay, so see, now one end of the alloy wire is connected to a battery that we have written, and then via a key it is connected to other end of the alloy wire. Your meter bridge is ready for the experiment. Yeah, for working. Now working, you will turn on the battery, plug in the key, right, and you will start sliding the jockey over the meter bridge wire. Okay, and till you achieve null point. So how does null point look? You know, see, this is how we will slide. Null point means deflection in the galvanometer should be at 0. Reading in the galvanometer should be 0. So suppose that null point is found at J. Suppose here it is found. So you can see this is my point J. Okay, here galvanometer is showing 0 deflection. So I will note down the reading of the length from A to J from the meter scale. Okay, so let it be L, 35 centimeter, 40 centimeter, whatever. So remaining length, because the total length of the wire is 1 meter, that is why it is called meter bridge. So remaining length J to B, remaining length is 100 minus L centimeter. You can write centimeter. So yeah, so we have found balancing length AJ and JB. Now, because it is the condition of null point means balanced Wheatstone bridge condition is fulfilled. Okay, so actually there is an analogy, there is similarity. This circuit now is a balanced Wheatstone bridge. This is your P. Okay, this is your P. This is your Q, unknown resistance. Okay, and AJ, A to J. There here they have written D. A to J. This is your AJ. AJ's resistance, and this is your remaining resistance. JB's resistance. Okay, and middle arm zero current because galvanometer is showing zero deflection. That is why you have found. Okay, so condition of balanced Wheatstone bridge is fulfilled. So at that known resistance, this is the resistance box is known resistance upon unknown resistance is equal to resistance of AJ portion, resistance of JB portion. Okay, now we don't know the resistance of AJ and JB. Let us substitute if we can calculate. Yes, so let sigma be resistance per centimeter of the alloy wire that you have used. So resistance per centimeter means resistance of 1 centimeter is sigma ohm. So what will be the resistance of L centimeter? Sigma into L ohm, and resistance of 100 minus L centimeter, 100 minus L into sigma ohm. So we have calculated the resistance of AJ and resistance of JB portion. Please substitute. Our function is to find out unknown resistance. So I have denoted known by K, unknown by U. Okay, so unknown's formula has been devised. Known is known resistance we know, and L we can read from meter bridge. So this is how we find out an unknown resistance. So this is the topic of meter bridge which is used to find unknown resistance. Okay, so thank you.